This conference will now be recorded.
Good afternoon. My name is Greg Wadley with CTC and Associates. I'm the Clear Roads Administrator. We're here for the final project webinar for the project entitled Efficacy, Cost, and Impacts of Non-Chloride Deicers. This research effort is led by Laura Fay at the Western Transportation Institute of Montana State University. Before I turn it over to Laura, I want to let everybody know that this webinar is being recorded and will be posted on the Clear Roads website later this week for viewing by you or your colleagues at your convenience. We also ask that unless you're speaking, please stay off camera and stay on mute today so that there's no background noise. However, if you have any comments or questions, please enter them into the chat box and we will address them at the end of the presentation. I think that's about everything for the housekeeping items, so I will turn it over to you, Laura.
Great, thanks, Greg. So thank you everyone for being able to attend the meeting. Most of the folks on this call were a part of the project. And again, we're going to be reviewing the final report contents for Clear Roads Project 21-03, Efficacy, Cost, and Impacts of Non-Chloride Deicers, or development of educational primers to support the use of non-chloride deicers. So moving into the meat of what the project is about, the goal was really to synthesize available information on non-chloride deicers to allow folks in the winter maintenance field to make better decisions about whether or not these are appropriate products for them to use. In order to do this, we did a literature search, we conducted some surveys, we evaluated the available evaluation tools that are out there, and we're going to go through each of those in this presentation. And the final outcomes of this report that can be found on the Clear Roads website, in addition to this recording, are the final report, as well as 4 primers or product information sheets on various non-chloride deicer categories. So before we get too far into this, I really want to acknowledge quite a few people. This was a team effort with Dr. Shi, and then all the folks at WTI that worked to make this happen. A big piece of this is the research, but the other side of this is the graphics and information sharing in usable formats. So a huge thank you to Neil for his role in helping create the primers. As always, we want to say thank you to the Clear Roads technical panel and also to Greg and everyone at CTC and Associates for helping to support these projects. So again, a quick overview of what we're going to talk about, including a literature review, the surveys that were conducted, the evaluation of the Clear Roads Qualified Product List Specification document, and then we'll share the educational primers that were developed. And then all of this, again, is provided in the final report. So jumping into the meat of what we did. So that first task was a literature review. And what we did is we scoured everything that was available on the web. We reached out at conferences and reached out to vendors. And essentially what we found were some major categories of non-chloride de-icing products. Overall, 46 products were identified as available currently for sale on the market that had information available on them. General categories included acetates, so that includes calcium magnesium acetate or CMA, potassium acetate, which we refer to as KAC, and sodium acetate, which is commonly called NAC or NaAC. Another category is formates, and for that we have potassium formate and sodium formate. And then there are a few products on the market that are blends of acetates and formates together. And another category identified by actually the project panel is the concept of agriculturally derived additives. So an important note that we included at multiple points throughout this project and in the final report are that agriculturally derived products are typically added to another product. So you might be adding, for example, a beet juice to a salt brine. There are very rare instances where you would use an ag product on its own. And then there's this experimental category, and there are quite a few products that would fall into this, but some of the examples that we were able to identify actual laboratory results on are potassium succinate and luvulinic acid. And so what we did for all of these is we took all of the available information we could find on what it is, any product performance data that's been provided on it, anything from the vendors that might include like a data safety sheet, so what percentage of each product is in there. So as much as we could coalesce into one document, we put together for these products. In addition to this lit review, we kind of took the perspective of, okay, yes, we're talking about non-chloride products, but what about other non-chloride options? And so the concept of using heated pavements came up, and we just did a very overview lit review, but we were able to identify quite a few documents on electrified concrete, use of heating mats, and then use of microwave additives in pavements. So if this is of interest to your agency, this is a great starting place for information on this. And last but not least, in the literature review, we actually looked at kind of anti-bonding or snow and ice repellent, water repellent surface treatments. So these are pavement treatments that may be applied to the surface as a chemical or blended within the actual mixture of the concrete or asphalt. And essentially what they do is they reduce the bond strength between snow and ice and the pavement. And this can be done a few ways. There's actually some really interesting studies out there on the effectiveness of this. And it is something to look forward to in the future and see how well these can maybe stay within the pavement and hold up over time. So another interesting concept of kind of a no de-icer option. So the whole section of the report on the literature review is provided, as well as all the references that can be found on the website. The next piece of this project was conducting a survey, and this was actually two surveys that we conducted. One was of state and local transportation agencies. You can see those highlighted on the map off to the right for folks that responded. A second survey was reached out to vendors and manufacturers of non-chloride de-icing products. So we wanted to know what products are folks using. Well, state and local transportation agencies told us that by far the most commonly used non-chloride product is the ag-based additive. There were 8 people that indicated that their agency is using these products. We provided a summary table of the exact product name, the quantity they use, the cost, application rates or application techniques, typical temperature range, where the product is applied, and then any special storage and handling notes. And so if you are interested in using these products, this is a great starting place. It will tell you kind of roughly cost-wise what you're looking at, application rates that other folks are using, and techniques, whether they're pre-wetting with it, blending it and using it in an anti-ice or anything like that, and typical temperature ranges. And we were able to put all this information together because we got a good response for these ag-based products. There were other non-chloride products that were indicated as being used, but not as commonly used. So here's a summary list of basically the BioMelt AG64, CMA, potassium acetate, sand, sodium formate, and then SPC 5000. So these were all indicated as non-chloride de-icing products used, and people provided cost information, application rate, blending ratios, temperature used at. So really applicable information. But also what you can get from this is that either we didn't hear from a lot of folks that are using these products, or maybe a lot of folks aren't using them. We're not quite sure the extent based on the response rate from this. But there is some good basic information to help folks with application rate and expected cost. One of the interesting takeaways from these products, as you can see, is that a lot of folks are using them on structures. So bridges or in a targeted application location. So that's an interesting application of these non-chloride products. We wanted to know why folks were using these non-chloride products, and by far, most respondents indicated that they're using these because they're seeing better performance and they're trying to reduce the impacts to infrastructure and equipment. So Typically, when you think of non-chloride products, you think of less corrosion overall, and so that's less impacts to your infrastructure and your equipment. But then there was also this environmental piece, but not that many people indicated that that was the number one reason they were shifting. So we'll talk about that a little bit more when we get into the evaluation of some of these products. We also wanted to know what folks could provide in terms of success stories. There were some really interesting examples of using certain products. One agency was able to find a 32% savings in salt usage from blending of products. Other folks noted that they were seeing and experiencing a residual effect on the road and lower working temp from incorporation of non-chloride products. And then other folks indicated that concept of structural preservation and improved safety from use of these products. So really valuable information. We did also ask folks if they do additional testing on these products. And this could have been to meet their spec or just for folks to know how this product is performing. And only 2 folks out of all the respondents indicated that they do additional testing. And I did indicate here the agencies, and there's actually a report out of Ohio from 2017 that provides quite a bit of data if folks would like to go back to that and look. We did ask folks if they use heated pavements just out of curiosity, and MDT was the only one that indicated that they do have heated pavements in their network. It doesn't mean other agencies don't have them. It just means we didn't hear from them that they did. So I mentioned we did 2 surveys. So that second survey was of vendors and manufacturers, and this was a very targeted survey. We reached out specifically to folks that have products on the ClearRoads qualified product list that are deemed non-chloride. And then we also reached out to as many vendors and manufacturers that we could find that sold non-chloride products. We heard from 8 different companies that provided information to us directly. And some of them provided a wealth of information, and some provided links to technical data sheets and safety data sheets. And in the report, you can see exactly what information was provided by each company. Off to the right of the company name are the different products made by each company that we have information provided for in the report. But just as a summary, you can see here on the left, we have a summary table of the different products that we got information on, basically what the product is, and then the general name of the vendor or manufacturer of that product. Versus on the right-hand side, we have the data from the different transportation agencies on what product they're using and what agency is using it. So the next piece of this effort was to evaluate the ClearRoads QPL specification document. And essentially, when you look into the ClearRoads QPL, you see that there's quite a few categories that could incorporate or only incorporate non-chloride products. So initially, these categories were identified. So liquid CMA, solid CMA, other acetates, products with 30% or more organic, so that would be your ag-based products. The experimental category for liquids and solids, and then additives that could be used for de-icing or pre-wetting. And that was our starting point for this evaluation process. So what we did is we summarized what's required testing-wise for each of these categories. And so if there's an X there, it's required to be collected for that category. So across the top, we have the QPL category, and then down on the left-hand side, we have all the different tests that are done. And what you can see here is that it is very uniform, the data that's requested for QPL evaluation, which is really good. That means you can do the best comparison possible between categories for each product. There is additional information requested for some of these categories, and we do provide that. But in terms of what we're talking about for non-chloride products, none of these jumped out as extremely important to consider at this time. But again, all this is summarized in the report. So what we did was we took all the information we were able to capture from vendors and manufacturers, as well as information available on the web. And we ended up being able to summarize quite a few categories here. So solid CMA, other acetates, liquid products with greater than 30% organics. We also created a summary table for acetates not on the QPL, liquids with more than 30% organic not on the QPL, and formate-based products not on the QPL. And we wanted to break these out because we wanted to show information we were able to capture for these products that are existing on the QPL versus other products that could potentially be on the QPL. I would like to note at this time that at the point in the project where we were working on this, we did not have permission or access to all the data that's provided to ClearRoads for QPL evaluation. So we had to rely on what the vendors and manufacturers were willing to provide or what was available in the published domain. So of particular interest when going through all the data, specifically for non-chloride products, what you're really going to want to look at is the biological oxygen demand and or the chemical oxygen demand. Nitrogen, phosphorus, cyanide are all elements of critical importance, as well as overall toxicity, corrosion performance, and then potentially some performance testing results. And because these are important for non-chloride deicers, we took a little bit of a deeper look at these in the report, and we're going to go through the relevance of each of these now. So biological oxygen demand, or BOD, is the amount of oxygen consumed by various microorganisms in the water. And the reason why this is important is because a lot of non-chloride products serve as a food source. So they cause elevated biological oxygen demand, and that depletes available oxygen or dissolved oxygen in the waterway. So this is typically used to assess the impact of these non-chloride deicers on water quality, and it's typically measured at 68 degrees. And so a big part of the report is assessing, is the current test method that's used, because it is used for water quality standards, a lot of times for water treatment facilities, does this apply in a great way to winter operations and to deicers? Some work that was done by the USGS looking at airport deicers found that this test method does not work as well for these non-chloride deicers because the food source or these microorganisms, they have to adjust to it. And so there's a lag in the BOD data response. And so you may need to extend the actual length of time of the test. Another piece of this was the test temperature. 68 degrees is pretty warm and atypical for winter conditions. So would a colder test temperature better mimic what's going on? Another piece of this to consider also is the concept of dilution. We put these non-chloride deicers on the road at a certain concentration, but then with precipitation, traffic, and as it moves through the environment, they likely get diluted. And what is the actual diluted amount that is making it to these organisms as they consume it? So all of these variables are really important as you consider BOD as a test method to evaluate these products. So I mentioned a lot of these already, including the temperature dependence of the test. So the warmer you conduct a BOD test, the higher BOD you're likely going to get to a point, as long as you're not killing the microorganisms. There's also various lengths that this test is done at. It is most typically done at 5 and 20 days, but it was proposed by the USGS that a 28-day test may be most appropriate for non-chloride deicers. One of the challenges that we had with this, there's actually a real wealth of BOD data reported, but it's reported in really variable units. So coming up with a consistent unit to report BOD would really help folks. And just that there is a lot of data out there that I mentioned. And so what we did was we converted a lot of the units to consistent units. So the equivalent of parts per million or milligram per liter, milligram per kilogram. And we graphed all these. And again, this is explained and blown up to a larger size in the report, but you can see here on the left-hand side of the graph, we have BOD for chloride products, moving into chloride with additives. And then in the green, we have acetates. And in the red, we have formates. In the light gray, we have glycols. Purple is ag-based. And then we have urea and succinates. And again, the data here is shown because it was available to us. There might be other data out there, but it wasn't discovered in the review process. But what you can take away from this is that there's kind of some general categories of BOD ranges that are important. Essentially, the chlorides and the ag and even the formate have fairly low BOD overall. And then you have this median category of acetates, glycols, and succinate. That the BOD values, while high, they're still not as high as, for example, urea, which has really high BOD. So in terms of maybe creating some categories, that might be possible when you have a large data set to work with. The other piece is chemical oxygen demand, and this is the measure of the amount of oxygen necessary to break down an organic substance in water. So this has nothing to do with the microorganisms, this just has to do with the chemistry. The thing about COD is that it's way easier to measure than BOD. So if possible, if you could use COD as a proxy for BOD, that could potentially save you a lot of time and money. And there is a test method that is approved to do that. It's used by the water treatment industry, but we did identify that there are some products out there that may have very high COD and low BOD, and so the actual value you would get would actually throw off your units. So at this point in time, we're still recommending folks go with a BOD measurement. We, again, took all the COD data we were able to find and we converted it all to similar units, similar to the BOD graph we just showed. And again, you see kind of similar trends with COD in that you have lower values for chlorides, formates, and ag. You have moderately elevated values for ag and glycols. And then again, you have urea coming out as the highest COD value. So moving forward with the evaluation of the specification document, we identified nitrogen as a key element to think about. And there's a couple different test methods that exist. So you can test for total nitrogen or total killed nitrogen. Nitrogen is a very important element in nature. You do need to have some of it, but too much of it can be harmful. So you want to be aware of what does your non-chloride product have and what could it be adding to the environment. On this note, urea is a de-icer that used to be more commonly used. It is apparently still used sometimes at airports, but it is basically composed primarily of nitrogen. So it's going to have a huge, or impart a huge nitrogen load on any aquatic system that it reaches. But this is not necessarily true for all other non-chloride products. So again, you're going to want to look at that base nitrogen concentration for your de-icers. Phosphorus is another important element to consider. So you might be looking at orthophosphate or total phosphorus. Again, phosphorus is a critical element in nature. You do need it for things to work, but too much is going to be bad for you. High concentrations can be harmful to water bodies and reduce available dissolved oxygen. So that feeds directly into that BOD-COD value that we were just talking about. Generally, high phosphate concentrations are associated with runoff. So as a rainfall or snowmelt occurs, it's going to pick up things from the environment and then bring it into waterways. And that, again, is going to cause elevated phosphate. There are some standards available out there. I just listed the Clear Roads one versus the EPA limit. And, this is something for ClearRoads to talk about are, the reasons why certain values were chosen, and it may be due to dilution factors or whatnot. But a key piece of the phosphorus is that a lot of ag-based additives add phosphorus at higher concentrations than you would expect. So if you are using an ag component, definitely run a total phos or orthophos test on it to see what you're contributing. And in the report, we provide a specific example with a state DOT where a company came to them and said, we will give you this ag-based product for free. It'll save us from having to dispose of it, and then you can use it essentially as a pre-wetting agent. But what we found was that the phosphate concentrations were highly elevated, well beyond what the state standard was. And so it created kind of a sticking point for getting permitting to use this product. So it's very important to run tests and know what you have and what you're working with. Another important element is cyanide. It usually is in the form of ferrocyanide or sodium ferrocyanide. And this is commonly added actually to rock salt as an anti-caking agent. And it can be also added to the salt that we consume at low concentrations. But usually it gets, diluted out, or you only get a small bit over time. But what folks have found is that around salt storage facilities, there can be elevated cyanide right around the facilities from just accumulation over time. An interesting piece of this is that some ag-based products actually naturally have cyanide in them. A lot of seed coatings use it as a natural protectant. So if you are, again, using an ag-based additive, run a cyanide test and see what kind of levels you're seeing in there. It may not be an issue. The cyanide may not be available, but it may be something you need to look at. And again, I provide some limits for cyanide in water and then ClearRoads and with the EPA for folks to consider. Another test that's required by the QPL and is discussed in the specification document is corrosion. And the test method used it's a modified dip test. And essentially it's cyclic immersion of washers in a fluid over time at 3% concentration. And the goal is that compared to water and salt brine, whatever product you have, it's 70% less corrosive than the salt brine. And here are just some general ranges of values for different products that were available in the published domain. And so there's probably a wealth of data that's been submitted to ClearRoads, and it's also published on their website. You can find each product's corrosion score that's been published. So that's great to have that information. If you are using one of these products for the sole purpose or partial purpose of it providing corrosion protection. Another piece of the ClearRoads specification document is friction or grip testing. And the test required on the QPL is actually conducted in a sealed humidity chamber. And you essentially apply your product to a pavement surface and you increase and decrease the humidity over time. And you measure the friction of the pavement surface as humidity changes. The big concern was that some products could potentially increase humidity on the road surface, creating dangerous conditions. So it's a good test. I don't believe it is based on a standardized test method, like an ASTM test method, such as the one referenced for corrosion. So that's something that the ClearRoads QPL committee could talk about, is maybe standardizing a test procedure and test method so that multiple labs could perform this test and have consistent results between labs. One thing this test does not do is it does not talk about how a product is going to perform in snow and ice conditions. And that's not something that's required, but it's something for consideration if that is the type of information the committee is interested in. The last piece of testing that we talked about was performance testing. The ClearRoads QPL specification document does not currently require any performance testing other than friction and corrosion, but there is a wealth of data out there on de-icer performance in ice melting capacity, ice undercutting, and ice penetration. And so we do review those in the report and provide some information. Overall, there's also calorimetry testing discussed in the report. Calorimetry testing is very accurate, and it can also be very expensive depending on who has the machine and who can run the samples. A newer test method that was developed called the mechanical rocker test appears to be the most cost-effective and consistent test results between labs and within a lab. So in terms of developing an ice melting capacity data set, that might be the route to go. We were able to find quite a bit of data on ice melting capacity from just rocker test results here. And so you can use this kind of as a reference guide for different products that have been tested and the different results. It is important to note that this test method is only currently approved for liquid products. It is not yet approved for solid products. And that's something for folks to work on, but it is a starting place. So the next task in this effort was to take all this information that we collected and to distill it into educational primers. So we wanted to provide very high level information on the general categories of non-chloride de-icers. So this is the acetate educational primer. Essentially what it provides is a general description of what acetate-based non-chloride de-icers typically are, pros and cons of using these. Along the vertical axis on the left-hand side, you can see we have effective temperature and eutectic temperature for various acetate-based products. And then we also have it compared to sodium chloride. We want everything to reference back to salt brine or rock salt because that is typically what folks are using across the country. We have information on application rates for the various products in liquid, solid, and pre-wet form, and cost information for liquid and solid. And then on the back side, we have information on impacts. So compared to salt, what's the relative impact of acetates on BOD or COD? What about toxicity, pavement performance? So impacts to asphalt or concrete, and then also impacts to the different metal types. So mild steel and galvanic steel. Galvanized steel. And then we have a general description of storage and handling and any special considerations that should be done. So we created these educational primers for acetates, formates, glycols, and then ag-based products. And I really want to stress that we did note in the report and on the primer that ag-based products are typically added, they're not used alone. And so part of the application rate box on this notes that you're not going to apply this single product at a typical application rate, you're going to blend it with something. We don't want folks going out there thinking that they can just buy a tote of something and just lay it out on the road and get de-icing performance, when in reality, they're probably not going to get it from that product. So in conclusion, basically what this report found was that non-chloride de-icers are a viable option in winter roadway operations. They are being used out there effectively, and there's actually quite a bit of data out there to support their use. We also found that the ClearRoads QPL collects a sufficient or a wealth of data, in fact, to assess these non-chloride products. There are a few things that the QPL subcommittee may want to consider moving forward, and that has to do with maybe how BOD data is used and assessed, and potentially with BOD if dilution wants to be considered, if test temperature, and then the units that it's reported in. The other component to consider as well are nitrogen and phosphorus. These elements are critical in the environment. They can both be present in de-icing materials, but they could also be influenced by dilution. And so is this an important factor you want to consider in the limit that you provide for folks to meet on the QPL? Another element, again, is cyanide and how present it is in the environment around your test facility. Have you even tested the soil around your facility if you know it's present? And what concentrations are you working with? Specifically, if you're using ag-based products, definitely test for cyanide, see what that level is at. And then do we need to have a dilution factor folded in if it's in a non-chloride product, because it's going to get diluted as it works its way through the system. Toxicity of these products is highly variable based on the species of product, the species that's tested. Clear Roads currently requires 3 separate species that cover kind of a wide range of flora and fauna, which are pretty typical for all toxicity testing. So I wouldn't necessarily make any recommendations about changing that, maybe aggregating more toxicity data to make decisions. But there is some general guidance from some work, including a previous Clear Roads project, on general toxicity compared to others. So one project found sodium chloride to be the least toxic to these species. And then as you work your way to increase toxicity, you have acetates, glycols, and formates kind of working your way to increase toxicity. So again, toxicity testing is important, but it's also important to have it in a side-by-side way so that you can compare it. So you want to make sure the same species are being tested. And one thing to consider with these, again, is dilution. What actual concentration is going to be present in the environment that these species might come into contact with it. And then another takeaway is corrosion to metal or corrosion protection. One of the big things that is common with these non-chloride products is folks say, we want to use it because it's non-corrosive. Well, that's not necessarily true. As you go through and you read the information, some of these products may be non-corrosive to mild steel, but they may be corrosive to galvanized steel, or they may have impacts to pavement. So it's really important to understand what your product might impact as you apply it. Additionally, we provided some guidance and thoughts on the friction and grip data that's collected. General guidance is, in the US, we're very conservative with our friction values. Friction is typically on a scale of 0 to 1, where 1 is great friction and 0 is going to be very slippery or poor friction. So anything 6 and up or 0.6 and up is going to be considered safe. Anything from 0.6 to 0.4 is going to be in that range of like, oh, we're getting to be slippery. And anything below 0.4 is going to be very slippery. And if you were out in the field measuring a friction value of 0.4, you would probably start calling out folks to conduct some winter operations if you hadn't called them out already. So I think, the major takeaways from this are that each product has its own potential use and benefit. But we cannot say that any one non-chloride product is better than another. They are each going to be beneficial in different ways. One may work at colder temperatures, one may be better for concrete pavements or a metal type on a bridge, but you as your agency need to look at all the data for each product and make a decision that's best for you and your agency. So we did come up with some recommendations, and again, these are just items for you as an organization to consider. But a lot came out of this in terms of evaluating the Clear Roads QPL specification document. Specifically, consider for some of the guidelines, for example, BOD, requiring units for how the data is reported so that you can start developing a wealth of data in consistent unit format over time. We also suggest that you consider modifying or adding to the corrosion test and requiring galvanized and stainless steel be tested as well, because these are common metal types, and some of these non-chloride products can affect these metal types versus mild steel. Also, we suggest that you consider looking at the limits for phosphorus, nitrogen, and cyanide, as well as some of the other categorical tests that you're done, and consider dilution, temperature, all the different pieces that fold into these different test methods and these limits. So the report provides a little more detail on all these topics, but another component of this was providing guidance on future research. For the BOD testing, we suggest that a future research project could look at using a modified BOD test method to evaluate these non-chloride products, or honestly all de-icing products. So you could look at temperature, test duration, and dilution to hone in on what is the best test method for winter maintenance operations. Another project could look at toxicity. We mentioned there is a wealth of toxicity data, but look at it specifically in the context of de-icers and the environment that these de-icers may end up in. So considering dilution, species, water and soil chemistry, temperature, and exposure duration, so test time for these different test methods. Other testing could include product performance. So future work, again, could look at this mechanical rocker test and actually do testing on some of these non-chloride products that we don't have published data yet on. And so that might be mechanical rocker test, ice melting capacity data collected for acetates, formates, and some of the glycol-based products that there is nothing available in the published domain for. Additionally, I mentioned, establishing a certified test method for solid de-icers using a mechanical rocker test. Exploring this friction test method, getting it standardized, and then if possible, considering how it relates to winter operations specifically. So with that, myself and Sean Ming would love to take any questions that folks may have. I will stop sharing.
Thank you, Laura. So we received one question from Mark Goldstein in Massachusetts DOT. And Mark asks about an agency reporting a 32% savings via including some organics blended with their liquid de-icers. Were comparable winters normalized for winter severity?
That is a great question. Mark, I can put you in contact with the respondent. It's a local agency out of Iowa, but I'm happy to connect you with the person directly. I'm not sure if they normalized. Yeah.
It's such a small detail. Thanks.
Right. Any other questions?
Let's see.
So
I see.
Clay from, you go ahead. You're seeing.
Oh, it's okay. Let's see.
Yeah.
Okay. Clay says, we discussed at our meeting last week how the ag products are not really, whoops, I lost you, are not really non-chloride de-icers. Correct. I got feedback via email from someone after the Clear Roads meeting about that. And while we already had that included in the report at multiple points and in the primers, we actually re-emphasized that even more in the report and in the primer. The TAC, the Clear Roads Project Panel, really wanted us to include an ag-based primer. And so we made sure that we covered that in this project, even though traditionally you would not say that an ag additive is a non-chloride de-icer. So we just had to reiterate multiple times that, yes, we are talking about ag-based additives, but the reality is these are blended, these are additives, these are not applied on their own. So hopefully we addressed that adequately in the revisions.
All right, anything else? All right, well, hearing nothing, thank you, Laura, for your time. Thank you to the Clear Roads group for joining in. As I said earlier, I will have this recording posted at the end of the week. And just have a great rest of your day and week, and we'll talk to you soon.
Bye, everyone. Thank you.
Thanks, everyone.
Thanks, Laura.